Good morning, everyone. I'm Cole Mahon. He's Victor. He's Minor. Mario. I just want to start off today by telling you a childhood memory I have. I was about 4 years old and I was getting ready for bed, and I just got out of the shower and I was brushing my teeth, and I was standing on my shower brushing my teeth in the mirror, and I was having the time of my life, and I slipped and I fell and I blacked out. I don't remember anything else besides falling. Went to the hospital, and I got this scar, and I live with that every day of my life. Every single day of my life, I have to think about the consequence of that event. Ooh, gosh, it just makes me mad thinking about it. Okay, now that I have your attention, we're going to talk about atomic radius and how it affects us, and we're going to give you some examples just so we know that you got the idea. Okay, atomic radius. You're all probably wondering what it is. Well, I'm going to tell you. Atomic radius is the distance from the nucleus to the outermost electron. One way we determine that is to find the distance between a nuclei of two identical atoms that are bonded together. Now we have an example here with chlorine. Chlorine has 99 pictometers to each one. You add that up, it's 198. You divide that by 2, and that's 100 pictometers. So that gives us our atomic radius.
Okay, so the atomic radius can be seen through three different types of trends. The first one being the group trend, which means going down the column, the outer electrons are getting further from the nucleus. As you can see on the picture, they increase going down and decrease going up the periodic table. Within each group, the atomic radius tends to increase from the top to the bottom. So for this example, which element has the larger atomic radius? Aluminum versus indium, you would check on the periodic table and you would see that aluminum is above indium, meaning indium has the bigger atomic radius. Another type of trend would be the period trend, which means they get smaller across a period because they are increasing in charges of a nucleus. So they would increase going to the left and decrease going to the right. So for the example, which element has the larger atomic radius versus carbon versus fluoride, you would see that carbon is closer to the left, which means it has a bigger atomic radius.
Alright, the third type of trend is the diagonal trend. You rarely see this, but it pretty much means that from the top of the right end of the periodic table, that's the smallest part of atoms, and it goes all the way to the diagonally across, and that it generally increases in size. So an example for this one would be which element has the smaller atomic radius. It would be nitrogen or silicon. So nitrogen is in the second period, and then silicon is in the third period. So the smaller one would be nitrogen because it's closer to the top. Next, we have positive and negative ions. This changes the atomic radius easily. An example, this is just group 1A. It's just an example. So there's one electron in the outer orbital. When you have positive ions, they cancel out, so they get smaller, as you can see by the second drawing. In the next part, for the negative ions, they always get bigger. So in the first drawing, we have one electron, and then in the second one, you add another one. So that means that there's more electrons than there is protons.
Hi, and welcome back. So in this example, what I'm going to do is I'm going to give you a few different elements, and we are going to try to arrange these elements in order of we're going to try to arrange it in order of increasing atomic radii. So we are going to go from small. So anyway, let me actually do that. Still getting used to the new pen. So we are going to go from small to large. That's how we are going to order these elements. And the elements that we are going to be given are calcium, rubidium, sulfur, silicon, germanium, and fluorine. So remember, I actually haven't yet made the video on the atomic trend over the periodic table, but remember, if I know I definitely said this a bunch in the last example on atomic radius or atomic radii, that the trend, the overall trend, is we are going to have small atomic radii up in the top right-hand quarter of the periodic table, and we're going to grow as we go across the table to large atomic radii. So this is going to be our overall trend. We're going to go from small in the top right to large in the bottom left. Let me actually undo all of that so we can have a lot of space to write on our table. So let's just go through and just highlight where all these elements are on the table. So let's start. Calcium is going to be right here. Rubidium is right here. Then we have sulfur. Sulfur is going to be over here. There's sulfur. Silicon is over here. Germanium is right below silicon. And fluorine is up in this part of the table. So now we've got these pretty much, you can almost see that the periodic table has almost done all the work for us. We've really got, all we have to do is just really just write down this order that we see them in. So we're going from small to large, so we're going to write down the order as we go across the table, from top right to bottom left. So let's just go ahead and do that. So the smallest element in this collection is going to be fluorine. The next smallest would be sulfur, then silicon, then germanium, then calcium, then rubidium. And this is the order of the elements from small to large. So anyway, hopefully you found this useful, and I'll see you in a future video.
Example number 1. Which atom is larger? Potassium or bromine? The answer will be potassium, because with the period trend, the atoms increase to the left, which potassium is on the left.
Okay, problem number 2 asks which atom is smaller, beryllium or barium. And so as you can see, since beryllium is the first element in group 2, it is smaller compared to barium. When going down the column, then the outer electrons are farther from the nucleus. And if you remember, the group trend, it goes up and down. So as you can see, beryllium number 4 is smaller than barium. Problem. Example number 3 asks to put these atoms in largest to smallest order. So if you remember, the group trend for this, it goes diagonally, and so the elements toward the bottom have their electrons farther from the nucleus. So the farthest one would be cesium, which is 55, and then if you go diagonal again, you see strontium, SR, and then you go all the way to the right at AR, which is argon, and then you go up one, which is fluorine, excuse me. Okay, and then we have the last one, number 4, which asks which has a bigger atomic radius, SR2 positive or SE2 negative. And so I'm going to start off by saying a negative ion is always bigger than a positive ion, so therefore SE2 negative is bigger.